What's up guys, this is Massey. Welcome to another video. In this video I want to talk about compound interest. What is compound interest? Compound interest is the interest that is added to the principal before new interest earned is calculated. So interest is calculated on the principal and on interest that is already earned. So it means that the interest keeps adding to the principal. So interest is paid at a regular time interval called the compounding period. What is compounding period? The compounding period is the interval at which interest is calculated. It can be annually, it means that 1 time per year, semi-annually 2 times per year, quarterly 4 times per year, and monthly 12 times per year. So here we have amount equals to principal times 1 plus I interest to the power of n. N is number of compounding interval. And I, which is interest, equals to P times 1 plus I to the power of n minus 1. And we know I equals to P plus I. Let's see some examples. Tim borrows $5,300 at 4.6% annually compound annually. How much will he have to pay back if he borrows the money for 10 years? So let's do it every year. Let's calculate it every year. So the amount after 1 year is going to be P times 1 plus RT. So we have 5,300 times 1 plus 4.6 divided by 100 times 1. So that will be 5,300 times 1.046. That's going to give me 5,543.80. Now for the second year, this number is going to be the new principal. So the principal is going to change. So the principal plus interest of the first year is going to be the new principal for the second year. So it's going to be 5,543.80 times 1 plus 4.6 divided by 100, or 5,543.80 times 1.046. That's going to give me 5,798.81. Next year, this one is going to be the new principal. As you see here, for compound interest, the principal keeps changing. $81 times 1.046, and that's going to be 6,065.56. That's the amount after 3 years. Now if you want to find it for fourth year, this one is going to be the new principal. So after 10 years, we're going to have the amount equals to 5,300 times 1 plus 4.600 times 1 plus 4.6 divided by 100, all the way to same thing, we repeat it 10 times. So it's going to be A equals to 5,300 times 1.046 to the power of 10, which is going to be $8,309.84. Now it says determine the future value of A, interest earned, I, if he invested a principal of P dollars for N years at I% annually for compound annually. So that's going to be the general formula. It's going to be P times 1 plus RT to the power of N. That's how we calculate it. And this part I'm going to make it as I. So it's going to be P times 1 plus I to the power of N. That's how we calculate it. Now, next examples. Laura's grandparents invested $5,000 at 4.8% annually compounded quarterly when she was born. How much will the investment be worth on her 21st birthday? So as you see here, we have compounded quarterly. So I is going to be 4.8%, which is 0.048 divided by 4, because it's going to be 4 times per year. So 0.048 divided by 4 is going to be 0.012. That's going to be interest per each compounding period. How many compounding periods we have? Because it's compounded quarterly, is going to be number of years, which is 21 times 4 times per year. So it's going to be 84. So A will be P times 1 plus I to the power of N. So A will be P, which is 5,000, 1 plus 0.012 to the power of 84. And when you calculate it, it's going to be 13,618.62. So that's how much it's worth after 21 years. Let's see the next example. On her 50th birthday, Trudy invests $10,000 at 8% compounded monthly. When Lena turns 45, she invests $10,000 at 8% compounded monthly as well. If both women leave their investments until they are 65 years old, how much more will Trudy's investment be worth? So let's start from the first person. P is 10,000. I is 8% divided by 12 because it's compounded monthly. So 0.08 divided by 12. That's going to give me 0.0066. And number of compounding period is going to be 65 minus 15, because it's from 15 years old to 65 years old, multiplied by 12, because you have 12 compounding period in each year. So it's going to be 50 times 12 is going to be 600 compounding periods. So number of compounding periods. A will be 10,000 times 1 plus 0.08 divided by 12 to the power of 600. That's going to be 538,781.94. Now let's see how much the other person earns. Again, the principal is the same, interest is the same, N is going to be different because it's going to be from 45 years old to 65. 65 minus 45 times 12 is going to be 20 times 12 is going to be 240. So A will be 10,000 times 1 plus 0.08 divided by 12 to the power of 240. That's going to give me 49,268.03. So if you find out the difference, 538,781.94 minus 49,268.08 is going to be 489,513.91 more than Lena's. Let's see the next example. Next example, it says Nicholas invests $1,000. How long would it take for his investment to double for each type of interest earned? 5% annually simple interest or 5% compounded semi-annual. So let's start with the simple interest. Simple interest, we said A equals to P times P plus I, or P times 1 plus RT. So it's going to be 1,000 times 1 plus 5% times t has to be equal to 2000. It means that 1000 equals to 0.05 times t times 1000. So t will be, if you calculate it, that's gonna be 1, it's gonna be 20, sorry. It's gonna be 20 years. It takes 20 years to make it double by simple interest. Now let's see if we have compounded semi-annually, how long does it take? I is gonna be 0.05 divided by 2 because it's 2 times per year. It's gonna be 0.025. Amount is gonna be 2000 equals to 1000 times 1 plus 0.025 to the power of n. We need to find out the value of n in this case. So we need to find out, we need to divide both sides by 1000. So it's going to be 2 equals to 1 plus 0.025 to the power of n, which is going to be 1.025 to the power of n. Then we can find the log of both sides. So n will be log 2 divided by log 1.025. Log 2 is 0.301203. Log 1.025, that's 0.0107. That's going to give me 28.13 compounding period. So I need to divide it by 2. So it's going to be approximately 14 years. So it is much faster when we use compounding interest. I hope you enjoyed this video. Please leave me a comment if you have any question, and I'll get back to you as soon as possible. Thank you for watching and have a great day.